Alright, all you dudes and dudettes out there, welcome once again to rockfreakinsolid.com. Keep in mind that the link to today's blog post will be in the video description. Come by for a visit. This week we're going to be making a 19-piece set of chromatic tubular drums. We're going to be using PVC pipe. Okay? Now, this is Monday, so we're going to do a little discussion on the mathematical formula to use to make the different sizes for the different notes. Okay? Alrighty. So, I mentioned this same formula for finding the length of a flute and where to put the finger holes. You need to know these two numbers. If you want to know more about the physics as to why this math works, go back and look at that post. That was last week's Monday, okay? Alrighty. Anyways, just to make this quick, we got centimeters up here, and we've got inches down here. This is the linear measurement for how far sound travels in 1 second at an average temperature and at sea level. Alrighty. You need to know the Hertz frequency number for each note. There'll be a link in today's post on the blog to the page that has all the Hertz frequency numbers for all the notes. Give that a visit too. Do that math. Use those numbers with this math. Now, you want to divide, if you're using centimeters or inches, you want to divide, let me get this in view here. Okay. Alright, so sound travels 34,357.31 centimeters per second. It travels 13,526.5 inches per second. Either one you use the base number if you're going to use centimeter measurements or inch measurements to find out the length of your pipes. I'll use the A example again. 440 A at 440 hertz, 440 cycles per second, waves through the air, okay? If you were going to divide, let's say inches, this by 440, you would get the wavelength for A in inches, if you use the inches. The wavelength for A in inches is about 30 3/4 inches long. Now, for like I mentioned last week, for making flutes, if you're using a tube that's closed on one end and open on the other for a flute, you only need it to be a half a wavelength long. These are open on both ends. They're not going to have any drum heads on them. We're going to be slapping the ends with a little piece of foam. See what I mean? And if you have a shorter one, it sounds higher. Got it? Now, find the wavelength and you cut to measure. That's how you do your tubes. A, B, A sharp, B, whatever. Now, something you should know, if you want to double if you double the frequency, it goes higher. If you want to half the frequency and make it lower, have your tubes capped on one end. So instead of, you can get a lower bass tone. See what I mean? It's a little bit more boomy. But a little on that. Sometimes if you're using PVC and you're getting end caps that go on it, these little things aren't really expensive, but if you're having like 19, 20, whatever, bunches of them, they're like about $1 each, or a few cents, $1 and a few cents each. It could get a little expensive. You might find it easier to just get a flat piece of plastic and cover it, but it needs to be solid. You can't just cover it over with duct tape or something, because then it'll just, like, for instance, let me show you with the, I'll cover it with this little piece of leather over here. Come on, let go string. My workshop is a mess. It doesn't quite sound, it sounds kind of muffled. You really need the solidity of a good end cap. So even putting it on there, you can hear that booms pretty loud. But again, ooh, there goes the door. The reason why that does that is because the sound has to go through this tube and travel back again in order to make that sound. So you're actually doubling the wavelength in these tubes. when you cap one in. All right, so remember that map, alrighty, and use that formula to find the lengths of your wavelengths for each note that you want to make your tubes at. Remember, once again, centimeters, inches. These are the numbers that you divide. Use the hertz frequency numbers of each note to divide these numbers by, and that'll give you the wavelength in inches or centimeters. Alrighty. Okay. You might want to write this down. Right. Pause the video right here. Ready? 1, 2, 3, go. Okay. Unpause. Write that down. There's a lot more information in the, well, maybe not a lot more, but important information in the post on today's blog post. Click over it, find it in the video description, come visit, and there'll be links to other information, the hertz frequency number table, and a bunch of other things. And also, like I did last week for the flutes, this week as well in today's blog post, I'll put a link to a very special chromatic tuning program. It's a free download. You play whatever instrument in front of your computer, and it'll show you, the frequency and everything. It'll make sure that you perfectly tune your instruments. Precise tuning is important. Remember that. It's a free download. Download it for free. It works just fine. It's awesome. I use it all the time. Well, not all the time. I usually like to use this. I mean, there's a link to where you can get these for pretty cheap too. But if you want to do something for free, it's a nice program. Download it. That's all for today. I'll see you next post on Wednesday when we discuss how we're going to set up the designs for how we're going to have our tubes standing up. It's a pretty simple idea. I'll see you then. Later.